Hello everyone. Today we are going to discuss about sterilization and disinfection. First, before starting that, I am going to tell you some terminology. The first one is sterilization, a physical or chemical process that completely destroys or removes all microbial life, including spore. So it is a process. Okay, it may be a chemical process or it may be a physical process which will completely destroy the microorganism, that is called as sterilization. Second one is disinfection. It is killing or removing of harmful microorganism. So it is also a process where you can kill the microorganism or you can remove the microorganism. The next one is disinfectant. It products used to kill microorganism or inanimate objects or surface, and disinfectants are not necessarily sporicidal but may be sporostatic, inhibiting germination of outgrowth. It means for doing the disinfection process, which product we are going to use, that is called as disinfectant. Next one is antiseptic, a product that destroy or inhibit the growth of microorganism in or on living tissue. So for doing the sterilization process, what liquids you are using, the product you are using is called as antiseptic. Next one is aseptic, characterized by the absence of pathogenic microbes. So aseptic means when a object is free from microorganism, we'll call it is aseptic. So these are the some terminology: sterilization, disinfection, disinfectant, antiseptic, and aseptic. Next, we are going to study about the methods of sterilization. So there are mainly two methods. One is physical methods, one is chemical methods. Under physical methods, we have heat, radiation, and filtration. Again, heat is categorized into two more types. One is dry heat, one is moist heat. Radiation also, there are two types of radiation. One is UV light, that is ultraviolet light, or ionizing radiation. And next one is filtration and chemical method. Now we are going to see about the radiation method. So UV light, it has a limited sterilizing power because of poor penetration into the most materials. Generally used in irradiation of air in certain area, example OT and TB laboratories. So this UV light, no, it has limited use. Why? Because it can't penetrate all the objects. That's why you have a limited uses. Mainly where you will use this method, will use in the OT or tuberculosis laboratories. Okay. The next one is ionizing radiation. The example is gamma radiation. It is a source of cobalt 60 and it has greater energy than UV light. So it is more powerful than the UV light and therefore more effective. And it is used mainly in industrial facilities. Example, sterilization of disposable plastic syringe, gloves, specimen containers, and petri dishes. So this ionizing radiation is more powerful and more effective. And what is the use? We can use in the industrial area, okay, where we are going to do sterilization of the any disposable syringe, okay, these gloves, and specimen container means where we are going to keep our specimen, and petri dish means that where we are going to do the test in the lab. The next one is filtration method. So it may be done under either negative or positive pressure. So you can use both, either positive pressure or negative pressure. Best known example is the membrane filter made from the cellulose acetate and generally remove most bacteria but virus and some small bacteria, okay, example like chlamydia and mycoplasmas, may pass through it. Okay, see, by name itself, filtration means filtering the this virus or bacteria, but if it is very small, it can penetrate the filtration process. Okay, example is like chlamydia and mycoplasma, they are very small in size. Those, the filtration does not technically sterile item, but it is adequate for the circumstances under which it is used. Main use for heat level substance, example is serum and antibiotics. So mainly it is used for the serum or antibiotics. And the recommended size after size filter that will exclude the smallest bacterial cell is 0.22 micron. The next one is sterilization by heat, which has two types. One is dry, one is moist heat. So first we are going to study about the dry heat. The simplest method is exposing the item to the be sterilized to the naked flame. You can see in the picture, okay, flame, by using the flame. And example is Bunsen burner for sterilizing what? Bacterial loops, knives and blades. So this is one example of dry heat, Bunsen burner. What we will be doing sterile in this? We will be using loops, knives or blades. Next one is hot air oven. The second picture, the down one. Hot air oven expose item to 160 degrees centigrade for 1 hour, and it has electric elements in the chamber, air source of heat plus an fan to circulate the air for oven distribution of heat in chamber. An oven without fan is dangerous. See, normally we have micro oven in our home. So this has a similar principle where you are going to set a certain temperature, and there is one fan system which will maintain the ventilation inside the my oven. Okay, and if there is no fan, it may be dangerous. So like, what is the temperature? We will set 160 degrees centigrade for how much time? For 1 hour. The next one is uses for metals, where you can, what are the types of things we can use in the my oven? That is metals item, glassware, ornament, oil, waxes, powders, and that is items that are lacking water. This item, there, like there is a lack of water, like this item we can use in the hot air oven. The next one is moist heat. See, dry means here heat you are going to use without water, but in the moist there will be a water. Uses hot water. Example, moist heat kills microorganism by denaturing the proteins. The first one is boiling. Quite common, especially in domestic circumstance. Everyone know this in our home. Like if you want to clean something, okay, if you want to make something antiseptic, if you boil that cloth or any articles, okay, there will be a removal of microorganism or destroying of microorganism. So the boiling is a method. Next one is Tyndallization. It is also a process which is named after John Tyndall. According to John Tyndall only this name came, Tyndallization. Lengthy process designed to reduce the level of activity of sporulating bacteria that are left by a simple boiling water method. So in what happened in Tyndallization process, no? So it is more powerful than boiling. Okay, if in the boiling some more viruses or some more pathogens still alive in the objects, means that can be killed by the Tyndallization process. So now we are going to study about how this process happened. In the Tyndallization, the process involves boiling for a period, typically 20 minutes, at atmosphere pressure, cooling incubated for a day. Then boiling, cooling, incubating for a day, and boiling, cooling, incubating for a day, and the finally boiling again. It means 3 days a process. What we will do, first we will be boiling for 20 minutes, then it will be cool. Next day again we will make it boil, again it will cool. So whatever microorganism or pathogen in between this time it is growing, it can be died. The 3 incubation period are to allow heat resistant spore surviving the previous boiling period to germinate to form the heat sensitive vegetative stage, which can be killed by the next boiling stage. And the procedure only work for the media that can be support bacterial growth, and it will not sterilize plain water. The next method of moist heat is pasteurization. It is used very commonly that any dairy product, if you have to keep for a long time, you will use this method, pasteurization. It aims to reduce the number of viable pathogens in liquid so they are unlikely to cause disease. And it is uses heat at temperature sufficient to inactivate harmful organism in milk and does not achieve sterilization. Temperature may be 138 degrees centigrade for a fraction of a second or 71.7 degrees centigrade for 15 to 20 seconds or 62 degrees centigrade for 30 minutes. See, this temperature and timing is based on the product on which you are going to use this method. Okay. Next method is autoclaving. So the standard sterilization method in hospital. This method mainly it will be used in the hospital. The autoclave works under the same principle as the pressure cooker. I think everyone, you people have pressure cooker in your home. So the pressure cooker principle and autoclaving principle is almost same way. Okay, where water boils at increased atmospheric pressure, that is because of increased pressure, the boiling point of water is more than 100 degrees centigrade. The autoclave is a tough double walled chamber in which air is replaced by the pure saturated steam under pressure. You can see this picture. This is the how this autoclaving machine is working, where we'll keep the liquids, how we'll give the steam. Okay, when how the door, it is the same procedure like your pressure cooker principle. Okay, so but it is used in the hospital site in the, that's why the different picture is, it look different. Okay, the principle like means working method is same for both. Okay, the air in the chamber is evacuated and filled with the saturated steam. The chamber is closely tightly. The steam keeps on filling into it and the pressure gradually increases. The item to be steriled get completely surrounded by the saturated steam, that is moist heat, which on contact with the surface of material to be sterilized and condenses to release its latent heat of condensation, which adds to already rise temperature of steam, so that eventually all the microorganisms in what even forms are killed. And the usual temperature achieved in 121 degrees centigrade at the pressure of 15 pps. Okay, at exposure time of only 15 to 20 minutes. By increasing the temperature, the time for sterilizing is further reduced. Like if you increase the pressure, you have to reduce the time. Okay, so normally we'll use 130 degree centigrade and 15 powerful this pressure for how much time, for 15 to 20 minutes. Next we are going to see the advantage of autoclave. The temperature will be more than 100 degrees, so therefore all the bacteria will kill. This condensation of steam generate extra heat. The condensation also allow the steam to penetrate rapidly into the porous material, and the autoclave items must be steam permeable, cannot be used for the items that are lacking water. So how we are going to monitor the autoclave? That means it is working or not. If you keep something on the autoclave, how you will know, okay, it is working in a good condition? The first one is physically. Use of thermocouple to measure the accuracy of the temperature. So to check the temperature, you can use this thermocouple. So second one is chemically. It consists of a heat sensitive chemical that change the color at the right temperature and the exposure time. So first one is physically, by checking the temperature. Second one by seeing the color. Okay, based on the chemical use or based on the time, it will change the color. So you can come to know, okay, it's going in a proper way. Next is biological, where a spore bearing organism is added during the sterilization process and then cultured later to ensure that it has been killed. So with this we have completed all the method of physical sterilization. In the next class we will be studying about the chemical method of sterilization. Thank you everyone.